project about a real application that is being tested these days in Israel. It's about mobile application for managing the safety and quality in construction site. My co-authors are Banu Tak, Indian students from Maryland that spent half a year in Israel, and Massimiliano Luzzi that attends this presentation from Polytechnic Ancona in Italy, and Matti Revivi, which is the development application from a company named Safeguard in Israel. And the project is funded by the Social Security Services in Israel and also by Ben-Gurion University. So my presentation will be about the general rationale of the project, taking advantage of the synergy between safety and quality in construction and the hypothesis behind it, the research methodology, the development of the application, the mobile application, and also the case study methodology. And then I will talk about the application itself, the architecture of the application, the implementation inside, and the findings about safety and quality monitoring, and observations and conclusions. So our main hypothesis is that there is a strong synergy between quality and safety, and that we can manage both quality and safety using the same tools, the very similar tools of monitoring activities and monitoring the quality of implementation of the activities or the safety of implementation of activities. And because of this, we can manage them simultaneously with similar application, with very similar tools, and then get much higher attention by the first line and second line management, and also the higher levels management of the construction company. So this is our hypothesis, and we want to test if we can take advantage of this synergy and enhance both safety and quality in construction. So this is our validation research. We developed safety indicators, 2 safety indicators. We developed one quality indicator, and then we monitored these indicators following the implementation of our mobile applications that I will describe as well. And we try to figure out if we can achieve a significant improvement in both quality and safety in the case study project. So the first indicator was safety indicator. We classified or categorized the safety behavior of construction workers according to 5 categories. Remarkably safe behavior, which means that the workers fulfilled without any limitation all the expectations of safe behavior, including personal protective equipment, the workstation, taking care of their teammates, the surrounding environments, and everything. I cannot detail it here, but we submit a paper soon to ASE, so you will be able to see the precise definitions. Safe behavior, reasonably safe, without taking risks, personal risks, and without putting colleagues under risk. Risks himself, risks other, low behavior, and the worst behavior is risk himself and others. We have a data collection form that we collect weekly in the same day on the same day of the week, on the same hour, and we normally will monitor at least 10 workers during a period of 2 hours, and this will produce a safety sample that can express or can represent the safety environment and also the safety performance of the workers. It looks like this. This is an example of a not so good profile of safety. We can see here that only, let's say, 50% of the behavior is under category 4 or 5, namely safe or remarkably safe, and 50% is under the expectations, risks himself or others or both. So we can, using this indicator, we can give each of the categories a weight. One for remarkably safe, 0.75 for safe, 0.5 for risks himself, and so on. And by multiplying the number of observations for each category, we can have a good expression of the safety culture in the site. And this is a proactive indicator that can predict the culture or the safety performance in the site. In the same time, we can split the observations into two categories: safe, category 4 and 5, and unsafe, categories 1 to 3, and then see what is the level of risk that we have in the site. The total of categories 1 to 3 indicates the level of risk. So this is the unsafe category, and this is the safe, and we can quantify easily the level of risk that the workers are found in their sampling or in their performance. In the same way, in a similar way, we developed quality indicator regarding structural or skeleton works. The quality indicator assessed the work, the quality of work of concrete works, and steel works, and formworks according to the basic requirements, according to standards, and we monitored it in the same time, on the same days, and in a similar way to the safety performance. This is the architecture of the application and the phases of implementation of the application. It takes about 2 weeks to establish the application in a construction site. It includes here the building the database for the project, including all the workers, all the equipment, all the entities, and then the database is automatically synchronized with the application. The application is mounted on a mobile smartphones, and phase 2 is the characterization and designation of each entirety using a quick response to the application. And then phase 4 is documentation of the control using a digital checklist. In this phase, the application is actually on in the site, and the data is stored to a cloud computer and synchronized with the project and company database, and then the application can be used for control and communication of the safety and quality. And at this stage, the data is available, and the senior management, all levels of the construction project and company can monitor the safety and quality, and the data is available for full integration in ERP system of the company. This is an outline of reports that produced by this application. The activities and services that are carried out with the application are preparedness assessment, survey and tasks, safety and quality surveys, and safety and quality tasks, instructions, daily safety quality audit, normally carried out in Israel by the foreman, the superintendent in the site, intervention and corrective activities, made also by the first line management, pre-work risk assessment. Pre-work include ladders, formworks, assessment of formworks, and others, and safety investigations in case of illness or in case of a safety an event of safety. It can be an accident or a violation of the regulations. And the reports are hazard assessment report. It is produced daily, documentation of the survey and inspection by the foreman. If something is not carried out in the morning, it should be carried out. We have a report that it has not been completed by the crane operator or by the foreman. Safety instruction notebook, data for work needed. For example, checking of guidance or training that workers should have had passed before carrying out an activity. Recommendations in case that something was found incomplete in the previous documents. And application of special control procedures such as crane validation or crane checks and others. And then lesson learned. So the application is wireless, medium, internet or cellular. Transmission rate is 5 seconds. Barcode is quick response. Operations is iPhone operating system or Android. And the database is SQL, HTML, and GET and POST API protocols. This is how this is an outline of who uses the application: foreman, crane operator, contractors and subs, team leaders, safety manager, safety officer in the company, and the construction company staff members, such as construction engineer, civil engineers, and deputy or vice president for operations, and so on. Reports produced by the application include formal reports required by the regulations, which normally implemented manually, now can be fully produced fully electronically and automatically. The application makes safety and quality office work totally unnecessary and completely electronically. 200 daily reports are produced based on the inspections made by the foreman and crane operator or the subcontractor. 35 weekly reports about the state of the safety and quality in the site, and safety 2 reports carried out by the foreman and subs. 500 crane checks reports, including all the equipment surrounding, including lift schemes, mechanical condition of the equipment, and so on. The implementation include also key parameters such as site level organization concerning safety, formwork, rebars, and concrete cast concerning quality. And the findings, here it's a pilot study carried out last year in Israel in a project in Ramat Gan. We can see the baseline, the pre-application. In the pre-application, we found only 48% or around 50% of the activities considered safe. And this is a safety indicator 2, safe, unsafe, and safety indicator 1, representing the quality performance, was 60-61. As you can see, upon the implementation, we had a significant improvement, and we found the convergence of the performance at the level of safety indicator 2 at the level of 95, 94, and the safety indicator 1, safe, unsafe, 80%, which means we reduced by the application the amount of unsafe activities from 50% here to 5% here. This is a country like my country with relatively low safety culture. We see here some pictures of the baseline before, very bad site layout, and after. Reasonably can consider reasonable. Here are the levels of safety indicator 60 and 48, and here 76 and 95. And here baseline, you can see very messy workstations, and here much better. Again, you can see some of the improvements in personal protective equipment, lack of personal protective equipment here, and here much better. Before and after. This is the quality. Again, in the quality, we achieved a significant improvement from 63 to 93, 94, very similar. And the difference between the two stages were tested using t-test, and the findings were found to be significant, statistically significant at 99.99%. Here is the concrete level before, leakage of concrete, segregation, much better using the application. And again, concrete cover insufficient here. Here 1.5 centimeter, it's in centimeters, it's about half an inch. And here, following the application, adequate. And so this is forwards, before and after. And we consider the improvement because of the involvement, strong involvement of the first-line managers, performance, and the construction engineer. And in conclusion, the study stresses the control, command, and communication of safety and quality by the first-line manager is a key factor. A mobile application can enhance and can stimulate this process. Performance measurement demonstrated substantial increase in safety and quality during the intervention phase. Reductions of 46% of unsafe activities, improvement of 20% in quality and safety behavior, and improvement of 30% in quality of the reinforced concrete walls. Thank you for your attention.